it's yet another series of lectures in computer science that we are bringing today for you people. So as you all must be following that we are looking at computer networks, and in the past few lectures we have been looking at various aspects related to computer network. So today's lecture will again be in the same series, and in this lecture we are going to follow up about our different protocols that we have been discussing, the various standard client server protocols that we are going to talk about. So if you recall, in the last lecture we were talking about the domain name system, and today we will be continuing our discussion on the domain name system only. So in the domains, basically we were talking about that, how the domains are configured and how the internet naming conventions are followed. So today in this lecture we are going to again take it up forward from there only. So we are seeing that the domain structure is actually in the form of a hierarchy, in the form of an inverted tree structure, and the root node is at the top, right? And then individual domains come, like for example here we can see in this figure that we have .com domain, .edu domain. Likewise we can have other domains also, and each domain is further, like each subtree is further categorized in the form of a subdomain, right, which can also have its node. And if you remember, we had also seen that no two children can have the same labels or the same name. So the name which is given has to be unique. That is how we will ascertain that the names are given which are unique names are given. So basically the information which is contained in the entire namespace, it has to be stored. So namespace means what are the unique names which the domain name system can be use for assigning to the different hosts. So we understand that we have to save all these names on a namespace, but then if you think that the whole information should be saved on a single computer, right, so it is again going to be very, very inefficient and also not reliable, right, because it is going to cost a heavy load on the system, and it is not reliable, because if that system fails, then the entire domain name structure is going to come crashing down. So therefore the idea behind this whole philosophy of namespace is to distribute the namespace across the servers, right. So like we have the we have the hierarchy of servers, of DNS servers. The same way we are going to provide a hierarchy of name servers also. So we have to do this. We have to divide the whole space into many domains, and these will be based on the first level, right. So the root domain will stand alone, that is, it will not have any subdomain. But after that we can create as many subtrees as there are first level nodes. So first level nodes means that the .com node or .edu node or .net node, different nodes can be there, and each of these nodes can further have a subtree. So because a domain is created this way, therefore it can be again very large. So DNS allows domains to be divided further into subdomains, or we can say that into smaller domain, and each server will be responsible, or it will be under the authority of that server, whether it is a large domain or it is a small domain. So in other words, what we are trying to say is that the hierarchy of servers that we are creating in the domain name system is that it will be a hierarchy of names also that will be created automatically. So if you look at the hierarchy of name servers that are being created, so under the root server you have the different first level domain name domain servers, like you will call them the edu server or the com server or the other servers, and within each of the subdomains you will within each of the trees or the subtrees under the root you will have further the subdomains. So that is how we are dividing the entire namespace, and we are creating a hierarchy. So this hierarchy is going to create two main purposes. Firstly, it is going to allow us to give unique domain names, and also we are going to bifurcate, or we are going to distribute the entire entire task of assigning names to the hosts. Now when you talk about the domains under a particular server, or what is the region, what is the range, or what is the level up to which a server is going to work, then you talk about something called the zone, right? So since we are looking at a hierarchy, so since the complete domain name hierarchy, it cannot be stored on a single server, so we say that it is divided amongst many servers. Now what a server is responsible for or has authority over is called a zone. So what is zone? Zone is that contiguous part of the tree which lies under one particular server. So if a server accepts the responsibility for a domain and does not divide the domain into smaller domains, right? So then the domain and the zone will refer to the same thing. So now servers, what they will do is they will create a file which is known as a zone file, and they will keep all the information of all the nodes under that domain in the zone file. However, there is a condition, there is a possibility that the servers will divide the domain into subdomains, right? And they will delegate part of this authority to other servers also, right? So in that case, what will happen, that the domain has been divided into subdomain. So your domain and zone now will refer to different things. So in one zone, the server can create several subdomains, right? So the information about the nodes in the subdomains is stored in the servers at the lower levels, with the original server only keeping some sort of reference to these lower level servers. So original server will actually, we cannot say that it is getting away with all the responsibility. No, it is not like that, but it still has a zone, but the detailed information it will not keep. It will only keep the reference to the lower level servers, and the lower level servers in turn are going to keep the details of all the nodes which are lying in their particular subdomain or their particular zone. So if you see in this diagram also, it is very clearly shown that there is a particular server, okay, say the .com server, and the .com server has a larger zone which it is dividing into several smaller subdomains, whereas the lower level server, its zone and domain is going to be the same, but for the .com server, its zone will be different, and because it is what it is doing is it is delegating part of its work. So there will be several subdomains which will be created within that particular zone. So it depends from the server and from the the number of hosts or the number of servers or number of subdomains which are created, that how this is going to work actually. A root server is a server whose zone consists of the whole tree basically. It is a complete tree. So root server usually does not store any information about the domains, but it delegates its authority to other servers, keeping references to those servers only. So root server is only going to refer to the other server. It does not store any information on its own. So there are several root servers and each covers the whole domain name space. Root servers are distributed all around the world. Why we are saying they are distributed all around the world? Again, the reason is the same, to bring in more efficiency and to bring in more reliability across the system, and so that the transfer of information also occurs faster. Because if one person sitting on one part of the globe has to contact a root server on the other end of the planet, then it is going to be an inefficient proposition. So therefore several root servers are installed, and each root server will have the whole domain name space to its account. Now, there is another type of servers when we talk about DNS servers. So, we talk about the two other types of servers also. One is called the primary server and the other is called the secondary server. Now, again primary and secondary doesn't mean that secondary is sort of lower in rank or than the primary. No, it is not that. This is also another philosophy of creating redundancy. See, the idea behind the whole thing is that because the internet is a unstoppable service, so therefore if one server goes down, the other has to be brought up immediately without any delay. So therefore, for every step, the redundancy factor has been incorporated. So primary server is a server that stores a file about the zone for which it is an authority. So it is responsible for creating, maintaining and updating the zone file. It stores the zone file on a local disk. So primary server will basically do three things: that it is going to create, it is going to update and it is going to maintain the zone file which is being created about the zone. Right. The secondary server will also have a copy of the zone file. The primary server will, it will give a copy of the zone file to the secondary server. The secondary server will store the local disk, right, but it can neither create nor update the zone file. So if any updation in the zone file is required, then it is only done through the primary server. Secondary server only keeps a copy. So secondary server will say that this is not updated, or an updated version of the zone file will be sent to the secondary server by the primary server. Again, there is also one more thing, that it's not that one server is the secondary server, so for all servers it will act as a secondary server. No, it's not like that. So the server can be a primary server for a specific zone and it can be a secondary server for another zone. So same server can work both ways, right? So basically both the secondary and the primary servers, they are both authoritative for the zones they serve, right? But it is only the idea is not to have levels of authority, but the idea is to have redundancy for the data, so that if one server fails, the other can continue serving the client. The only idea behind this is this. So DNS basically, when you are talking about the domain name system in the parlance of internet, so then we look at it as a protocol, right, and it can be used in different platforms. So in the internet platform, when we look at the DNS or the domain name space, that is the tree, that is originally divided into three different sections or three different types of domain names. So there can be generic domains, there can be country domains and there can be inverse domains. So if we, if first thing is that generic and country domains of course are very significant, but inverse domains are not known. Inverse domains means that if you give a host name, you would get an IP address, right? So it is like, inverse way it is going to work. So if to find the name of a host when the given IP address. So these domains are not, now they are deprecated, they are no more used. So the two DNS which is used in the internet, the domain name systems is, one is the generic domain. So generic domains basically they define the registered host according to their generic behavior. When we first discussed about domain name system, we said that it is going to be depictive of the behavior of the organization or the nature of the organization. So each node in the tree will define a domain which is an index to the domain name space data. So there can be n number of generic domains which can be used, right? So like arrow and .net, .gov, info, org, etc., right? So for depending upon what is the behavior, what is the purpose of the organization, we can have a generic domain name. The second type of domain name which is given is the country domain name. Now country domain section uses 2-character country abbreviations for domains, right? So the second label can also be used in countries like the USA because they will have some abbreviation for the state also. So they will have something like CA.US US. So United States, for example, so it will have subdivision of the US also, but in case of India we don't use it this way, we simply write .in. So the country domain for India is .in, right. So this way, country domains can also be given. So these are the three types of domains, which can be used in the internet. Now how does one get new domains added to the DNS? So this is again done by a registrar. So registrar is nobody, but it's a commercial entity which is accredited by the International Corporation for Assigned Names and Number, the Internet Corporation for Assigned Names and Numbers. So this is an American multi-stakeholder firm group which is not for profit, and they are responsible for coordinating and maintenance of procedures of several databases related to the namespace and numerical spaces of the internet. So they ensure, that the network is stable and it is always secure in operation. So the registrar will first verify that the requested domain name is unique, and then he will enter it into the DNS database. Of course, this is not free. A fee has to be paid by the client for this, and many registrars are there in each country. There are different registrars where a person can go and get the domain name registered. So to register, the organization has to give the name of its server, that is where the website will be hosted, the IP address of the server, okay, and then you will have to give the domain name. So this information is to be provided to the registrar so that they can register your domain name. So this is how domain names are organized on an internet, and we also understand that how domain names can be registered, what are the authorities which register the domain names, and the core principles which are followed, that is reliability through redundancy, is followed in case of DNS server. So the second type of protocol that we would like to do today is the FTP protocol, or the file transfer protocol. This is another very important standard protocol which is provided by the TCP/IP protocol suite, and this is used for copying a file from one host to another. So when you are downloading a file from a computer, from a server to your computer, or when you are storing a file on a remote computer, that is you are uploading any file, then the service that you are using is the FTP service. So we will see in detail how basically this FTP works as a standard protocol of TCP/IP suite. So transferring files from one system to another, it looks like it's very simple and straightforward, but then this also has to it also has some problems or some issues in it. The first issue is that the two systems, they may use the different file name conventions. The two systems from which the file is being transferred, they may have different ways to represent data, and the two systems may have different directory structures. Directory structures means folder structures, because when we are talking about exchanging of files on the internet, then of course these problems can be very, very common, because the architecture, the hardware and the software configuration of the two systems may be entirely different. So therefore, when a transfer of file is taking place from one system to the other system, all these three things need to be tackled, that is the naming conventions, the storage convention and the directory structure of the file. And these problems have all been solved in a very simple approach by the FTP. So we transfer files, we can also transfer files using HTTP like we had seen earlier, but FTP is always better because it allows transfer of larger files, okay, and using different file formats also. So therefore FTP is the most preferred protocol when people want to upload or download any kind of file using the internet. So if we look at this architecture of the FTP, how the FTP works. So basically this is again a client server architecture, and the client wants to request a file from the server. So we can see at the client's end we have the user interface using which the client is going to send the request, and both the client and the server, they have some control processes, and they have some data transfer processes. So therefore we can see that two types of connections will occur between the client and the server. The first type of connection will be the control connection, and the second type of connection will be the data transfer connection. So the data transfer or the data connection is the connection which will allow the movement of file, but the control connection is going to allow or is going to coordinate this kind of transfer. Also we will see that how when multiple files are going from one computer to the other, from one client to the other, or one client to the server and vice versa, then also how this is going to work. So basically in the FTP there is a separation of commands which has been done. That is, the control commands are separate and the data commands are going to be separate. So this makes the FTP very, very efficient. So the control connection will use very simple rules of communication. So we need we need only to transfer a line of command or a line of response at a time. Data connection will be more complex rules because variety of data will be transferred, variety of data will be processed. So two connections we have in FTP have different lifetimes also. Lifetime means that the control connection will remain connected during the entire interactive session. During the entire duration, the control connection will remain live, whereas the data connection will be opened and then closed for each file transfer activity. So it opens each time the commands that involve transferring files are used, and it closes when the transfer is happened, the file has been transferred. So basically when a client is connecting to a server using an FTP connection, so the control connection will remain open for throughout the lifetime of the connection. But during one control connection, there will be n number of data connections which will be opened and closed. If there are n number of files which need to be transferred, then n number of data connections will be opened and closed. So data connections keep opening and closing, but the control connection will always remain open until it is finally closed by either of the client or the server. So when the user starts an FTP, the control connection opens and it will remain open, right? And with which are the ports, like we had seen in HTTP, it was the port 80. In TCP, there are two ports which are used. Port 21 is used for control connections and port 20 is used for data connections. So these are the two ports on which FTP communication will take place between the client and the server. Now control connection basically it's the similar approach. When we will see Telnet also, we will see how this works. So it uses the NVT ASCII character set as used by Telnet, and communication is achieved through commands and responses. So the simple method is adequate for the control connection because we send one command or response at a time. So we have a set of commands which are the control commands, and we keep sending those commands and every command has got its code also. So each line is terminated with a 2 character, that is carriage return, and line feed end of line. So during this control connection, commands are sent from the client to the server, and for every control command, a response is sent from the server to the client. So commands which are sent from the FTP client control process are in the form of ASCII uppercase characters, uppercase letters, which may or may not be followed by an argument. So every FTP command generates at least one response, right? And a response will also have two parts. Just like we did in HTTP, we had seen how the HTTP response is framed. Likewise here also. So the response will have two parts. First will be a 3-digit number followed by the text. So the number will be actually the code and the text will be the description or the status of the command, how it is going to work. Thank you.